tutorial will point out 5 common mistakes made by students in the CXC CSEC multiple choice exam.
700 years ago, the Kurupiya samurai developed a technique for maths so effective that everyone passed their CSEC exams. Legend says it was so powerful that it drove the samurai insane. Fearing it might destroy everyone, the monks took the scrolls containing the technique and buried it in the Kurupiya mountains. 700 years later, an unambitious lessons teacher with various hygiene problems unearthed the scrolls by accident. He will now teach you the way of the samurai. Technique 1. Hidden Fist.
Alright, so let's explore the technique called hidden fist. So the name suggests that something is hidden, that the person doing the question may not be aware of. So here we have a question, and of course the question here is just to solve for x. But there's a simple hidden trick in the question, and I'm going to do the wrong thing first because a lot of people in the CXC exam will make this mistake. So I think we all know we need to multiply out the brackets first. So everybody in this bracket gets multiplied by 4. So we will get 4x minus 4. See, both people get multiplied by 4. Now in this brackets, everyone gets multiplied by the 3. So we say 3 by 2x is 6x, and we put back this minus sign, and 3 by 5 is 15, and there was a minus sign here to begin with. And this is equal to minus 12. So I've already made the mistake. You think you can spot the mistake? Well, it's this guy here. Because everybody in this brackets not only gets multiplied by 3, but by negative 3. So 3 by 2x is 6x. Remember, this 2x is secretly positive. So a minus multiplied by a positive will give us a negative, fair enough. But the 3 by 5 is 15, but a minus by a next minus is a plus. And a lot of students would forget this plus sign here. And that would throw off the whole question. And believe me, in the multiple choice, they will cater for an answer that has this, but had the previous mistake in it. So a lot of students would say, hey, I'm on the right track. But the examiner knows, right? So once we figure out that a minus and a minus is a plus, and we don't forget it, we can quickly complete the question. We're going to say 4x, but add up all the x's first. 4x minus 6x is minus 2x. And over here we have, if we want, minus 4 plus 15. That should give us positive 11. And everything here is just equal to minus 12. So it's just simply to solve for x quickly. Throw across positive 11, get minus 11. And well, minus 2x is equal to minus 12 minus 11. Can't believe I need my calculator for this. Minus 12 minus 11 is minus 23. So when we solve for x, please don't forget, when the minus 2 is a multiply, when you throw across a multiply, yes, you get a divide, but the sign does not change. And if we work this out, I believe we will get positive 11.5. Because when you divide a negative and a next negative, you get a positive. Okay? And well, in the multiple choice, you could either have 11.5 or 11 and a half. Okay? So be on the lookout for that. So while we're on the subject of minus signs being hidden, let's try another type of question that can come in the exam that also involves a kind of hidden negative sign. So let's try B. So in the meantime, you could probably write down part B in your books. And you could probably try it, start it before I do, if you want. So B, another question where we want to solve for x. I need to write this kind of big. There's something that you need to see. 2, well, I need all the space, so I'm going to erase the b here. So we have 2x on 5 minus x minus 2 over 3 is equal to 1. So the problem here is that we have these denominators, the 5 and the 3, and we need to get rid of them. So what I'm going to do to get rid of the denominators, a common technique is to find the LCM of the denominators. So the LCM of 5 and 3 is 15. And here's what we're going to do. Well, something that you need to know in maths. Whatever we do to everybody on one side, you can do anything in the world. Just make sure you do it to everybody on one side and everybody else on the other side. You have to be fair to both sides. So the LCM of 5 and 3 is 15. So a common technique is to visit everybody and multiply the numerators by 15. But if I multiply all the numerators, that means the top, by 15, that means I have to multiply the other side by 15. Now 1 is not a fraction, but 1 is obviously 1 divided by 1. And you notice I'm being fair to both sides of the equation. But all the numerators on this side get multiplied by 15. So I have to multiply all the numerators on the other side also by 15. So let's see the advantage of doing this. And I'm going to make the mistake. Remember, there's a hidden minus sign somewhere. 5 into 5 is 1. 5 into 15 is 3. 3 into 3 is 1. 3 into 15 is 5. And 1 by 5 is just, well, 1 by 15 is just 15. So let's see. You notice all the denominators change to 1. And when you divide something by 1, the value doesn't change. So if I have 7x divided by 1, there's no need for me to write the divided by 1, obviously. So let's go here. 2x multiplied by 3 is 6x. Don't forget this minus sign here. And this 5 here, you have to be careful. Remember, there are 2 items on top here. So I know the 5 is closer to the 2. So your brain might say, hey, let's only multiply the closest guy. Everybody here gets multiplied by the 5. So you get 5x minus 10. Notice I multiply both of them by 5. And the whole thing is divided by 1. So I'm not going to write the divide by 1. And 1 by 15 is 15. Where is the mistake? You see this minus sign here? You see how it's smack in the middle? When you have something in maths that's smack in the middle, it really belongs, you should pretend it belongs to everybody on top. But here's the thing. You might think that this minus sign only belongs to the x. The truth is it belongs to the whole numerator. A very common trick in the exam. So you can imagine it like this. The whole top in brackets. So this minus sign belongs to the whole top and we put brackets to signify that. The examiner will not put the brackets, believe me. So this whole thing needs to be in brackets. And when you put these brackets, the signs will change, believe me. So what's going to happen here is minus by positive is a minus. And a minus is a plus. I commonly play this trick on my students all the time. And without fail, and most of them get it wrong, right? And I can see how easy it is to forget. So don't forget and make notes. And guys, this is things that the examiner really looks forward to tricking you with. So take down up to here and don't forget the positive sign here. And now we just have to solve for x. 6x minus 5x is just 1x. But nobody puts 1. Just put the x. And the positive 10, throw it across to become minus 10. And 15 minus 10 is 5. So x is equal to 5. Alright, so that there is the secret of the hidden fist.
Technique 2. Cornered Tiger.
Alright guys, so let's investigate technique 2, the cornered tiger. Now this question deals with finding the area of a triangle, but it's not your regular formula that you're going to use. The base by height divided by 2. Sometimes, remember, the base multiplied by height divided by 2 only works if they give you the length of the base, the length of the vertical height. And of course, if you don't have any of these, you can't use this formula. So I'm going to show you a formula that works when you don't really have the base and the height, they give you other things about the triangle. So here we have a triangle. Here you have two sides, and you notice you have the two sides and the angle in between the two sides. So you may have already come across this formula, and it's actually on the formula sheet, but a lot of students don't know the common A and the common B and the capital C. This is a capital C. Let me write it bigger here for you. The capital C, and you're supposed to put a little degree sign here. This formula, the capital C is the angle. So for you to use this formula, what you have to do, it only works if they give you the angle and the two sides bordering the angle. So here's how I want you to interpret it. Pretend the angle is the tiger, right? The angle is the tiger, right? So the angle is the tiger. And two people are hunting the tiger. So what they want to do is hunt the tiger and put it in a corner. So pretend we have two spears, right? So the samurais have two spears. The cover of the markers are the spears. What's the correct way to corner this tiger? Won't it make sense to go like this towards the tiger? So for this formula to work, you have to make sure the samurais are working towards the tiger and trying to corner it. Would it make sense if this samurai turned his spear? I don't think turned is a word, but let's go with it. Turned his spear around and start to jab this way? No, the tiger would get away because the tiger is over here. So what you want to do is pretend that you're going to corner the tiger. I'm going to show you another example to show you that how you can get tricked. So how would you find the area of this triangle? Well, to find the area, it's a half. The two spears, right, are the two sides of the triangle. That's A and B. So it's 6 and 5, and then you multiply by sine of the tiger. The tiger is the angle in between, which is 30 degrees. So you just need to type that in on the calculator. So it's a half, 0.5. A half is the same as 0.5. Multiply by 6, multiply by 5, multiply by sine 30. And for this triangle, we get 7.5 centimeters squared. So that's the area of this triangle. Let's see if I can trick you before we move on to the official question. So let's draw another triangle here. I'm going to ask you to find the same thing. I'm going to ask you to find the area. So another triangle here. So let here be 40 degrees. Let here be, let's use small numbers just for the example. Let here be 10 centimeters and let here be 8 centimeters. And the examiner asks you to find the area. First of all, the tiger is here. He is the angle. So this spear is going towards trying to corner the tiger. But this spear, the length of this side is over here. He isn't even bothering with this tiger. This tiger is going to get away, obviously. You cannot use this formula because this formula only works if the two samurais are trying to corner the tiger. So if I had the length of this side and I already have the length of the head, and the two samurais were jabbing the tiger this way, right? They would be able to corner the tiger. So don't be fooled. You cannot use this formula to find the area of the triangle. All right? The truth is, to find the area of this triangle, you need more information, to be honest. Okay? So, well, not more information. You will actually have to use something called the hard sign rule and find more of the sides. You have to get more information. The point is I'm making, your brain will tell you, because you're seeing two sides, you will try to use this formula. And I've seen students make this mistake over and over. When you have a formula, there are certain conditions you are allowed to use the formula. You can't use a formula because the formula is close to you and you think it's convenient. Okay? You must have valid reason to use it. Okay? All right. Let's find the area of this triangle. I love this question. The reason is it really tests your knowledge. So you have A, B, and C. And they tell you this side is 8 centimeters, but they do not give you the length of this side, and they give you the angle here as X, and they want you to find the area. So we're going to get an expression for the area here. Now here's the thing. What do these two lines mean? These two lines mean that this side and this side is the same. So this is obviously an isosceles triangle, making here 8 centimeters. And here's the angle in between that the examiner specified. Can we use this formula? Can we corner the tiger? Well, we have the length of this side and the length of this side, and the tiger is facing this way. So it seems that the samurai spears are facing towards the tiger, and they can go ahead and try to corner it. So yes, we can use this formula. So let's find an expression for the area. A half. A and B are the two sides, or the two spears. So we have multiply by 8, multiply by next 8, multiply by sine, and the C is the tiger. We don't have a value for the tiger, we just have X. So how do we work this out? 8 multiplied by 8 is 64, right? Obviously. And we have to find half of 64, so we're going to get 32. And over here we just have sine X. We cannot work out sine X on the calculator because we need the value of X. This is the answer that you're going to see between A, B, C, and D. This is the expression for the area for this triangle. Alright? So I really hope that you understand the concept of the cornered tiger.
Technique 3. Left fist high, right fist low.
Alright guys, so let's investigate technique 3. Now I'm going to use this as this specifically applies to matrices. And I'm going to use this as an excuse to review the determinant, adjoint, and inverse and point out the mistakes quickly. Let's start with the determinant. Let's say you have to find the determinant here. When you ask a student, hey, find the determinant, they know they have to cross multiply something and minus something. But what they multiply and minus, they usually sometimes do it wrong side. So this is to help you to remember the order. Here's the correct way to find the determinant. You always multiply this diagonal first. 4 by 3 is 12. And as soon as you multiply this diagonal, no matter what you get, you must put that minus sign, no matter what. Then you multiply the other diagonal. So 5 by 2 is 10. And of course, if you work this out, we will get 2. Positive 2, in fact. That's the correct answer for the determinant for that matrix. So what's the mistake students make? Well, when it's time to find the determinant, well, they multiply this diagonal first. So they say 2 by 5 is 10. They put the minus sign. And then they say 4 by 3 is 12. But if you work this out, you will get minus 2. So you see, one of them gives you the opposite answer. So how do you remember which one to multiply first? Well, like the technique said, left fist high, right fist low, right? So you get a kind of pattern this way, right? So you see from this fist to this fist is a diagonal this way. So it's a really effective way of remembering it, right? So that's the first way of using the left fist high, right fist low. Let's find the adjoint of this matrix now. So we got a different color here. What is the adjoint? Well, the adjoint of the matrix, you are supposed to switch these two numbers. Once again, the ones that you are switching is the left fist high, right fist low. So the 3 will go here and the 4 will go here. Some people switch these two by mistake. They will switch the 5 and the 2 by mistake. Okay? The 5 and the 2, the other diagonal, does not move. They in fact just become the opposite. Now when I say the opposite, you look at him, forget about the 2. Ask him, hey, what sign are you? You are positive 5? So you become negative 5. And then you go to the other one and say, hey, what are you? You are positive 2 today. I'm going to change you to the opposite, which is negative 2. So these two do not move. They just become the opposite versions of what they are, but they remain put. the left fist high, right fist low. This diagonal is the one that switches position. So this is the adjoint for this matrix. So what is the inverse of this matrix? Well, whatever you get for the inverse, whatever you get for the determinant, in today's question you get a 2. You automatically throw it underneath a 1. The 1 is understood. So if I got 3 here, it will be 1 on 3. And when you do that, just put the adjoint next to it here. And this here is the inverse of this matrix. So I just went through like a full matrices question in all the steps in actually finding the inverse, right? Which involves the determinant, adjoint, and inverse. Well, and at the end, inverse. Now, another question, well, sometimes, that's a question I get all the time. Is it okay to leave the half inside here? Or do I have to multiply everyone inside here by a half? Now, when you are multiplying by a half, you're already dividing everyone by 2. Okay? So sometimes in the multiple choice, well, let me put the space here. Instead of seeing the half outside, they might write the answer like this instead. You see the 3, the minus 2, the minus 4, minus 5, and the 4? Well, they will divide everyone inside by 2. And whatever could be simplified, like minus 2 divided by 2 will give you minus 1, and 4 divided by 2 will give you 2. So you would see this instead in the multiple choice, minus 1 and 2. So you can see this in the multiple choice, or you can see this answer in the multiple choice. Both of them are equal. Okay? Alright guys, so let's, just so it sticks in your head, let's do another question with a small trick in it. Nothing too big. Let's find all 3 things here for this matrix. Right? I have the extra time tonight, so I don't mind doing it. Alright. So, let's see. The determinant here. Remember, left fist high, right fist low. This diagonal. Minus 3 by 2 is minus 6. As soon as you multiply that diagonal, you must put the minus sign, no matter what. Then you multiply the other diagonal. 5 by minus 1, well, look at that. It gives you another minus. So you end up with minus 6 plus 5. So the two minus signs touch. Minus 6 plus 5 is minus 1. So the determinant is actually minus 1. Let's find the adjoint. Finding the adjoint is easy. Remember, this is the one that you're switching. So the 2 goes here and the minus 3 goes here. The other 2 do not move. They just become the opposite versions of what they are. So if you have minus 1 here, he becomes positive 1. And if he is positive 5, he becomes negative 5. So what is the inverse? Well, whatever we get for the determinant, we throw it underneath a 1. Right? And we put the adjoint here, which is this answer. Now this one is going to be slightly different to simplify. Let me explain why. This one is actually easier. In the last one we had a 2 here. But 1 divided by minus 1 gives you minus 1. So what's going to happen? We just have to multiply everyone inside here by minus 1. Giving us minus 2, positive 5, minus 1, and positive 3. So most likely this is the one that you'll see between A, B, C, and D. Not this one. I really doubt. I've never seen, whenever there's a minus, like a 1 or a minus 1 outside, or a really nice number outside, they always multiply all the inner numbers by the nice number outside. Alright guys, so that was left fist high, right fist low. Technique 4, Grasshopper, double snake paw. Alright guys, so let's investigate the 4th technique here, double snake paw. Alright, so let's say they want you to expand or simplify this expression here. Let me do the wrong thing one time. So you see what the examiner, or how they trick you. You see a squared here and think everybody inside here is going to get squared. So you're just going to put 4x squared minus 9, right? And, well, you just simply square everybody inside here. And then I say, hey, that is wrong. And then I usually ask my class, hey, Can anybody point out the mistake? And of course, they all laugh at the student and make fun of him, right? And they say, well, obviously, the correct answer is positive 9, not negative 9. Because when you square a negative, you get a positive. Well, Grasshopper, this is also wrong. Okay, so let's look at what the double snake paw is about. Whenever you see squared, if I say 5 squared, I know 5 squared is 25. But squared means to multiply by itself. It works for this concept works for something simple, right? So obviously the double snake here, right? So if it works for something simple, it works for something complex as well. So this is like an illusion. This is really 2x minus 3 multiplied by another 2x minus 3. It's double. So you put the same thing twice next to each other. And how do you multiply this out? Well, it's simple. All you have to do, I went through this in another video, but let's go through it again. Let me get something to block this. Oh, we got a piece of paper here. 1 second, guys. All right. So what you can do, you block him, right? And then you multiply both of them by 2x. And then you block him and multiply both of them by minus 3. So let's go through this. Multiply both of them by 2x. So I have 2x here, and I'm multiplying the whole brackets by 2x minus 3. Then I'm going to multiply the same brackets by minus 3. So 2x by 2x is 4x squared. Remember, x by x is x squared. And 2x by minus 3 is minus 6x. Minus 3 by 2x is minus 6x. 3 by 3 is 9. But a minus by a minus is a plus. There's a quick thing here. You see the squared here? People say 2x by 2x is 4x by mistake. X by x is x squared. I know most people know this, right? But when you're under stress in the exam, you're going to forget these small little details. Also, 4x squared is here. Minus 6x is minus 12x plus 9. This is the final answer. You can't simplify this any more. All right? So, let's apply the double snake paw to a slightly harder question. Okay? That's B there. So you can write it down in the meantime. Just give me a few seconds to erase the board. So I'm doing B now. Okay, in B, you have 4x minus 2 and 2 and squared. Once again, don't make the mistake and just say 16x, 4 and 4. Do not say, I'm just going to square everybody in the brackets. This really means, well, let me write it here. 4x minus 2 on 2 in brackets multiply by the next 4x minus 2 on 2 in brackets. That is how you interpret something like this. And even further, since we're multiplying, what we can do is pay attention to the top first. So you work out this like in part A, and then afterwards you work out the underneath. You say 2 by 2 is 4. So the underneath is easy. So for the top, you're already looking at 4x minus 2 multiplied by the next 4x minus 2. So once again, using the same, I'm going to hustle this now. You block him, multiply both of them by 4x. Block him, multiply both of them by minus 2. So you're going to get 16x squared minus 8x minus another 8x plus 4. So you're going to end up with 16x squared minus 8x minus the next 8x is minus 16x plus 4. And now the underneath 2 by 2 is 4. But the whole top gets divided by the 4. So how are you going to simplify this? Really easy. Now, this really means everybody on top gets divided by 4. Not one person, all 3 of them. So 16x squared divided by 4 is 4x squared. Minus 16x divided by 4 is minus 4x. And 4 divided by 4 is 1. And you notice I remember to put the signs in between. So this here is the final answer for this question. Okay? Right. Now guys, I know this is like a, this one here is like a paper 2 question, right? The first one is like a paper 1 question. But guys, remember this is a special year where your entire mark is basically based on only 2 things, your SBA and a paper 1. So you have to ask yourself, right? Do you think you're going to get a normal paper with normal multiple choice questions? Or is the examination board going to test the limits of your knowledge and give you harder questions? Because only 1 question counts for everything. Well, the majority of your grade this time. So I would really like to give you some advice here. Hope for the best, but prepare for the worst. Okay? You have to remember that, right? So whenever I'm doing these videos for the multiple choice, I'm going to be doing harder questions just in case, right? You got to cover all grounds just in case. All right? So not trying to scare you, but that's how life is. You have to prepare for the worst just in case. Okay? So while we're on double things with squares that make things the double, let's try some functions that involve the double just in case. Right? So let's say they give you the function fx. Fx is equal to 2x minus 5. And they ask you in part 1 to find f squared. F squared x. Right. First mistake. You know what most students are going to do? They're going to say 2x minus 5 and they're going to square the whole thing. And of course, I just showed you that if you square the whole thing, you're already taking this and multiplying it by itself. And you expand on the brackets and you simplify it. And a lot of students would just say, all right, I did it correct. Time to leave the exam room. But this is wrong. Okay, let me explain the correct thing to do here. You see where that squared is? That squared is hovering over the f. So how do you write this? Using a double snake paw, f squared is f x. And how do you work out functions? You usually work backwards. So I have to take x and put it into f. Now if I do that, remember, this is fx here, right? If I had a tree here, I would throw the tree inside here, meaning that I would erase the x and put what here? Tree. And whatever I got for that answer, I would put it into f. But we don't have a nice number here. We have x instead. So if I have x and I throw x into f, that means I erase x and replace it back with x. I have just wasted ink from my expensive marker, right? So when you just throw x into a function, you get back the same exact function. But this new answer, we have to put it into f again. So remember, let me write back this here. This is 2x minus 5. I have to take this expression now and throw it into f. So when I go to this f, which is this, wherever I see x, I have to erase it and put this 2x minus 5 in brackets. And I have to simplify this now. Everyone inside here gets multiplied by 2. 2 by 2x is 4x. 2 by minus 5 is minus 10. Minus 5. So we have 4x minus 10 minus 5 is minus 15. That's the answer for this question. And please note where the squared is. Where the squared is will determine how the working is performed. Right? All these questions are going to be very closely linked. So in part 2 now, they have f squared minus 1. Well, this is f minus 1. The squared only applies to the f. So all we have to do is put minus 1 into f. So let's do that. Here's 2x minus 5. I erase the x and put minus 1. So minus 2 minus 5. Well, 2 minus 1 is minus 2. Minus 2 minus 5 is minus 7. So when I put this minus 1 into the first f, I get minus 7. This new answer now, I have to put it into f again. So I'm running out of space here. Actually, I could do it here. So this f is 2x minus 5. Erase the x and put minus 7. 2 by minus 7 is minus 14, minus 5. This will give me minus 19. So the final answer between A, B, C, and D will be minus 19. All right. So look at this question now. You notice in these two, the square is hovering over the f, but in this one, the whole fx is in the brackets, and then you have a squared. Well, guess what? That is the one where you actually squared. So in part 3, they are asking you for fx, and the whole thing is in brackets squared. So fx is equal to 2x minus 5, and the whole thing is squared. This is the one where it more relates to part A and part B, right? So take note of where the square is. And I'm not going to work it out, but this is really 2x minus 5 multiplied by 2 and x minus 5. But I'm going to work, well, sorry, let me work it. Let me just give you the answer so you can work towards it. If you multiply this out, you will get 4x squared minus 20x plus 25. I've already simplified it as much as I can. Okay? So this is the final answer that you might see on the answer sheet. Okay? Alright guys, so that was double snake paw. Tricky samurai. Alright guys, so let's explore the last one for tonight. The tricky samurai. Now the tricky samurai is a kind of, it deals with well, circular theorems, and it creates a kind of an illusion, meaning that when you see the question, it will resemble something that you did in class. But when you look closely at it, you're going to realize, wait, it's not the exact same thing. So the tricky samurai kind of makes you use the wrong formula because it looks similar to something else. So let's start off with the cyclic quadrilateral, and then we'll move to this question. What is a cyclic quadrilateral? Well, in a cyclic quadrilateral, the sides, it's a four-sided figure that fits inside the circle, but all four corners must touch the circumference. So I'll give you an example. 1, 2, 3, 4. Look at this carefully. All four corners touch the circumference, and it must touch the circumference. And in a cyclic quadrilateral, the opposite angles, that's these two, always add up to 180, or these two. So that means, let me get a different color here. If here was 100 degrees, the opposite side has to be 80, because the opposite sides must add up to 180. Similarly, if over here was 110, over here would have to be 70. The opposite sides must add up to, the opposite angles, must add up to 180. Alright, so another rule. Let's say I have a circle and I have an arc. So here's an arc. Whenever you have an angle starting at the beginning of the arc, let's say it hits the circumference and bounces back to the end of the arc. There must be an angle here. Let's assume the angle is 10 degrees. I'm just assuming. If you have another angle starting here, it hits the center instead and bounces back. This angle will always be twice the one touching the circumference. So here will be 20. And it actually looks bigger. It's always twice as big. But this one tricks people in the exam. For this rule to work, remember how you would draw like an eye in comics? Like you could see an eye here. If I draw the nose and the mouth, you could see a face, right? So you see how an eye looks? An eye is just basically a triangle with a curve and a little piece of a circle there. For this rule to work, if I put this here and this here, you'll kind of like see the eyeball. So this eye is looking this way and this eye is looking the same way. For this rule to work, both eyes must look the same exact way. Okay, so you have to be careful about that. Okay, so I'm gonna, well, I don't know why I drew this. Well, I could just use the paper here instead. So I probably put this here, right? And I'm gonna show you how this kind of tricks you in this question. So they want you to find this angle here. So let me give you the wrong answer. We work it out and see if you got this as your answer. If you got 55 as this angle, you fell for the trick. The samurai has tricked you. Because I know what you did. You say this is a cyclic quadrilateral, 1, 2, 3, 4, and the opposite angles must add up to 180. So you just subtracted this from 180. So you just said 180 minus 125. Of course, you're going to get it wrong in the exam. This is not a cyclic quadrilateral. Let's look at this carefully. It's 4 sides. I have no problems with that. This corner is touching the circumference. This corner is touching the circumference. This corner is touching the circumference, right? But this corner is not touching the circumference. It's touching the center of the circle. So this is not a cyclic. It looks like a cyclic. So here's the other one now. This one resembles kind of like this, I guess. There's one angle touching the circumference, and there's one touching the center. Notice this one is touching the center. So a lot of people say, well, the one touching the center has to be twice the size of that. So they will say 125 multiplied by 2. And of course, somewhere between A, B, C, and D, you're going to see a 250. The examiner knows this is not going to work out. This is not going to work out. Why isn't it working out? Look at this, right? I'm going to draw back this shape here. I don't want to clutter the diagram too much. Over here is the 125. And here's the angle they're asking you to find. If I draw the eyeballs like this, the eye and the eye, remember for the rule to work, both eyes have to be looking in the same direction. He is looking this way and this one is looking that way. They're looking opposite directions. So that's the total opposite of the scenario. So you see how the samurai is tricking you. It's making the question look like these rules, and of course a lot of people will fall for the trick. What you need to do is find this angle first. This eye is looking this way, and this big eye is looking this way. So he is touching the center, this big one, but he is touching the circumference. This big eye will be twice the size of this eye. So he is 250. Okay? Right? This eye. But the examiner didn't ask you to find this. He asked you to find the one behind. Remember, a circle is 360 degrees. So if a full circle is 360 degrees, you just have to take the 250 and minus it from 360. So 360 minus 250, and the actual answer is 110 degrees. All right, guys. So I really hope that these 5 tricks will help you in your math exam. In fact, I know it will help you in your math exam, right? These are popular tricks. Now, how did I come up with these tricks? I just didn't go to a paper and just came up with 5 tricky questions or theorems, you know. This is years of experience giving questions to students and testing them and realizing that, hey, they're making the same mistakes over and over and over. So I saw a pattern. Now there are other mistakes that students make. And in my next video, provided I get time, I'm going to point out 5 more common errors, okay? And guys, don't worry, by the time we finish, you're going to be a strong samurai, okay? So until my next video, take care and don't forget to subscribe and share. And if you have any questions, giving you problems, and you want me to work it out in my next video, WhatsApp me. My number is in the description below. Take care, guys.